This is video 3.3.1, and the objective of this video is to be able to use logarithmic properties to expand and condense expressions, because we're going to eventually be solving logarithms, and in order to do that we need to have some properties about logarithms in order to condense and expand them. So first of all, these are the notes you'll want to take on the properties. There are 3 properties we'll be using in this video, and you'll get some more notes in class, so be prepared to take a few more notes once you get to class. The first rule is the product rule. And the product rule states that if you have a product inside of a logarithm of any base, then you can rewrite the logarithm as a sum of the 2 factors in your product. Log base b of m plus log base b of n. So m times n was inside of my logarithm. I can separate that into a sum of 2 logarithms. I can do the same thing with quotients, but of course it's going to be a little bit different. So now a quotient is when you have log base b of m divided by n. This separates into a difference, log base b of m minus log base b of n. These 2 rules follow directly from what you would have learned about exponents in class in the past. So whenever we have 2, remember logarithms are asking for the exponent and they're giving you the base and the result, the product, and your goal is to find the exponent. So when we talk in class we'll see a little bit more why these rules work, but for now we want to jot them down and start practicing them. The final rule that you need to know is the power rule, and the power rule states that if we have a power inside of our logarithm, in this case n to the y power, we can drop the power in front and it'll now be y times log base b of n. So these 2 rules are very simple, but they often get mixed up. So you definitely want to write them down, study them, and make sure that you practice them correctly. We're going to look at some examples here. We're going to start by expanding, and then we'll look at condensing in the final couple of slides. So our first example is log 10 of x, log of 10x. One thing to remember, whenever we have logs that don't have a base, the base is 10. Log base 10 of 10 of x. So we're going to start by expanding. 10x equals, well, 10 times x. So we're going to use the product rule. And we're going to expand this log of 10 plus log of x. But I know log of 10 is equal to 1 because 10 to the first power equals 10. So I'm going to simply write 1 plus log of x. And I've fully expanded and simplified along the way. Question 2 is going to be similar, but we're going to start by using the quotient rule. Natural log of e to the third over 7 can be rewritten as natural log of e to the third minus natural log of 7. But I notice natural log of e to the third can be expanded further. So I've used the quotient rule, but now I'm going to use the power rule to expand 3 natural log of e from the natural log of e to the third. One last thing I'm going to do is I know natural log of e is just 1, so I'm going to replace that with 1. So my final expanded result is 3 minus natural log of 7. Hopefully you're noticing that's slightly simpler than what we had in question 2, which is one reason why we expand expressions, because sometimes we can simplify things as we go. The third example is another example of the power rule. We're going to drop the power of 4 out in front of the logarithm and get 4 log base 7 of 5. And the fourth example, natural log of the cubic root of x. So we have to remember that the cubic root is really just a power. It's the 1/3 power. It's the reciprocal of the root. So 1/3 is the reciprocal of 3. Now I can use the power rule to drop the 1/3 out in front. And this is an expanded expression from the previous written example. The next couple examples will look at more complicated, so pay close attention to some key problems that usually come up. So in this first example, notice we have powers and we also have a product. It's x squared is to a power, square root of y is also a power, and we also have x squared times the square root of y, so we have a product and a power. Biggest thing to notice is that we can't do the power rule unless everything is taken to the same power. So everything inside has to be raised to the same power, and since we have 2 different powers on the inside, we're going to start with the product rule. Separate it out, and then we'll use the power rule. So product rule first, then the power rule. Key thing to remember is just do the power rule last. So we did the product rule and we separated into a sum of two things. Now we'll use the power rule and drop our exponents out in front. And we fully expanded our expression. In example 2, we have a similar case, but instead we have a quotient with the product in the denominator and powers in the numerator and the denominator. So what we're going to do is, again, we're going to start with the quotient or the product rule, but let's start with the quotient rule and get rid of the division that's going on here. We'll separate this with the quotient rule and write it as a subtraction of the numerator minus the denominator. Then we're going to separate and use the power rule just for the first part, because that is now fully simplified. The second part, though, notice is a power y to the fourth, but it's also a product. So remember, product rule before power rule. Power rule should come last in an expression. So what we're going to do now is we're going to separate this by the product rule. One key thing, though, that you should notice is that everything's being subtracted, because that whole thing was being subtracted. Remember, both of those pieces were in the denominator, so we want to make sure to keep that going and subtract each of them, because that log base 6 of 36y to the fourth, that whole thing needs to be subtracted. So now I've got the first part of the expression I'm going to copy down, but I'm going to continue simplifying the two second logarithms that are in green there, log base 6 of 36. Well, I know log base 6 of 36 is 2 because 6 to the second is 2, so I've simplified that. Minus, well, now I'm going to use the power rule on the y to the fourth logarithm and drop the power of 4 log base 6 of y. I fully expanded this expression. It's not necessarily simpler, but you'll see when we solve equations again why we do all of this work and why we need fluency with it. Let's take a look at some examples going the opposite direction. So now we're going to condense. So this means that we're going to make the logarithms smaller and not make them multiple logarithms, but we're going to try and condense them into a single logarithm. So we have log base 4 for both of these parts of our sum, and we're going to start by condensing them and make them one logarithm. And we're going to use the product rule to do that. Log base 4 of 2 times 32, which equals log base 4 of 64. This is really nice because I actually know what log base 4 of 64 is, because 4 to the third power is 64, so my answer here is 3. Here's one key reason why condensing is so nice, because sometimes we can go all the way and actually evaluate the answer. Question 2, log of 4x minus 3 minus log of x. So I see a subtraction, so hopefully you're realizing this is the quotient rule. So I'm going to use the quotient rule because it states the difference of two logarithms is equal to the quotient of the logarithms. So I've condensed this and I'm done. Third question. Looks like we have coefficients in front. The 1/2 and the 4 are coefficients of the logarithms. So the first rule, just like when we expand, we use the power rule last. When we condense, we use the power rule first, because of course we're working backwards. So we're going to start with the power rule. This is important because we want to work in a certain order, otherwise we'll have non-equivalent statements. So once we have the power rule established, then we'll use the product rule to combine and condense this further. And this is your final result. This is as condensed as you can get. Example number 4 also has some coefficients, 4, 2, and 1/2. But in this case we have subtraction. So let's start by using the power rule everywhere and bringing the powers onto the inside, just like we did in example 3. Then we'll move on to using a simple property of the distributive property. I saw that there's two things being subtracted, so I can subtract the quantity of the two. This is important because I know I'm going to have to use the quotient rule, but the question is what goes in the bottom is the entire thing inside those parentheses. That's the denominator of my logarithm. So the quotient now becomes x to the fourth on top, because of course that first expression divided by b squared times the square root of y. So I actually use two properties here. I use the quotient rule to create x to the fourth over those things because of the minus parentheses. And then I also use the product rule to put the b squared and the square root of y in the same denominator. So this is fully condensed. Again, we went backwards. Backwards tends to be harder than forwards, but backwards is actually going to be more beneficial for solving equations. So we want to get good at both. Here are your checkpoints for this video. Your multiple choice question wants you to expand the expression. So expand it as much as you can, simplifying as you go. It's log base 9 of 81 over x. Here are your four choices, A, B, C, and D. Your free response question wants you to do the opposite and try to condense the expression that you see here. Remember to carefully try to follow the order of operations and do your best to describe what your answer would be in the Google form. Bring your questions into class, and hopefully you got your notes written down so we can add to them when you enter class.